Okay, so we're learning the last two shortcuts today. You can see them in the title. Let's read through the first sentence and figure out which one we are looking at. Two angles and the included side of one triangle. Remember we talked about included in the last section, the one right in between. So looking at these two shortcuts up here in blue, which one would be the two angles with the included side? ASA, okay, the one right in between the two angles. So we're going to need to label these pictures with markings that would follow ASA. So let's say I talked about this angle being congruent to this angle. And we'll pick this angle congruent to this angle. What sides would I have to have a mark on for ASA? Yes. Yep. So that would be a picture that would go with angle, side, angle. So the order of the letters in the shortcut is hugely important. Just like with SAS, the angle is right in between the two sides. With angle, side, angle, the side is in between the two angles. Okay, so let's look at this one. We have 3 givens and only 5 steps in this proof. So over half of it doesn't require a whole lot of thought. Okay, so we're going to put our givens down. There's also another step, because I told you there's only 5 lines in this proof that we could easily fill in without thinking about it. Which one? Number 5. What's going to go right here on the left?
Triangle LMN is triangle PON.
Okay, so we'll talk about that congruent statement in a second, but whatever is here in your proof is going to be your last step. That's what we're trying to do in the end. Okay, so let's talk about the congruent statement, make sure we have it in the right order. So if we're going LMN, what's the other one? PON. Okay, you just filled in a large majority of the proof right here. So let's mark up this picture with the things that are congruent. That way we can see what shortcut we're going to use. MN is congruent to NO, so those two are the same length. A lot of you aren't putting marks on your pictures in the homework and then you're confused on what shortcut to use at the end. This is a fail-proof way to know which one you're using. So LNM, if we go LNM, they're talking about that angle right there, is congruent to PNO, which is that angle right there. So looking at this picture right now, we have what's written in blue are congruent, the 2 angles here and the 2 sides here. In order to use what looks like we're going to do is angle, side, angle, we have to say something about these right angles, because right now all we've said is that they're right angles. So we have these 2 pieces of information, but we're going to need a third in order to use ASA. Yes. Anyone know what we would say? I don't know if we've been over this one yet. Really good guess. Not definition of right angle. Definition of right angle would be talking about 90 degrees. No, another good guess. I don't think we've been over this one, so I'll tell you what this one is. If you have right angles and you want to use them as congruent angles, the reason is all right angles are congruent to each other, which is true. This right angle is always congruent to another right angle. They're always 90 degrees. Okay, so now we have a side here. We have 2 angles, and the side is right in between the 2 angles. So this is an ASA proof. Any questions on that one? Okay, so let's look at the other one. Two angles and a non-included side. Okay, so this one we're looking at, as in the shortcut, we have two angles and then a side not in between the two angles. So if I told you that these two were the sides that were congruent, the ones on the picture, tell me what two angles I cannot pick. Let's just look at the first triangle. What two angles can I not pick? Yes. D with M. Okay, if we picked D and M, it would be what? Angle, side, angle. Okay, so we don't want the ones that are around the side. We want two other ones. Okay, so let's say I did pick D. Which one would be the congruent one on the other one? It's angle Y. Okay, we can't pick D with M, so I have to pick, yep. And that goes with P. So now this is a picture of angle, angle, side. Two angles and then the side that is, a side that is not in between them. So let's write a congruent statement in the right order. You can pick any order for your first triangle. C, D, M, sure. Yep. PYT. Questions? All right, let's try one more proof for today then. We have two givens. We don't have anything marked on the picture, so we're going to do both, write the givens down and label the picture. So we'll get these givens up here. Okay, so you'll notice that I gave you a little hint, but remember that these go hand in hand. If you have parallel lines in your given, you're going to have sentences that have if parallel lines. Okay, so X, Q, let's mark that these are parallel to each other with little arrows on here. And that's all we can really put on there. So there's not a symbol for bisect, but we'll be able to say something because of that. Okay, so we're going to start with the if parallel lines. Let's number these angles, okay, so we don't have to use 3 letters. So let's do them all the same. Let's do 1, 2, 3, 4, 5, and 6. Now, I've given you a hint that I want you to use 2 parallel line statements. So looking at those parallel lines, what angles can we say are the same because of that? Give me one. 2 and 6, no. 1 and 6. Okay, so angle 1 congruent to angle 6. Okay, that's right here and right here. What's the reason? If parallel lines. Good, that's from chapter 3. Okay, what's another set for the same reason because of the parallel lines? We could say 3 and 4, but that doesn't have anything to do with the parallel lines. Yep. 2 and 5. Okay, same reason. Are those also alternate interior? All right, so we have these two. Now we could have talked about the vertical angles, the 3 congruent to 4, but then it wouldn't have turned out to necessarily be angle, angle, side, and I want to do an example of that. So we've got These two, the green ones we talked about, 1 and 6, and also 2 and 5 congruent. Now let's use this information right here, because we haven't talked about what that tells us. So XR is going to bisect QT. So what got cut in half? Which segment? QT just got cut in half. So what do we know about it? Okay, so what would that be?
TM is congruent to MQ.
So QT got cut in half, which means we have congruent segments. So how did we know that? How did we know these were the same? Yep, the bisect up here told us that. So that is definition of bisect. All right, so we can say what we're trying to prove. And they filled in the congruent statement for us. So we don't have to fill in that second one. And this was a picture of, yep. Questions? Anyone still need this slide? Okay, last slide then. All right, there are going to be situations where you have overlapping triangles. It makes it a lot easier to draw them separately. So I'm going to go through an example here. So if they give you a picture like this, where we have two overlapping triangles, we have one that's right here, and then the other one is right there. It's better to draw them on your paper completely separate from each other, because then we can label them a little bit easier. So if they gave us these segments being congruent, we're going to want to pull them apart and draw them separately, labeled, so that we can put BC congruent to CD and AC congruent to CE. Okay, it says right here, angle C is congruent to angle C. If you look up here, see how they share this angle? Well, that means they're the same angle right here and right here. So if you draw them separately, it's a lot easier to put your markings on them, and you can easily see what shortcut they're wanting you to use. So you will have some overlapping triangles in your homework. Draw them separately on your paper so you can mark them up with the congruent parts. Questions on that?